This video is going to be an applied extension of the previous video where we talked about buffers and how you can make a buffer. One of the ways is just to take a weak acid or base and its conjugate and mix them together. And another way is to use excess weak base with strong acid, excess weak acid with strong base. And you can look a little more closely at the previous video for the details on that. So what I have here is a little spreadsheet that I thought up and my awesome peer tutor Jackson made into a reality. And it has possible combinations of things, and in this case we have HCl, which is our strong acid, and what we're really dealing with there is just H+. We have HF, which is a weak acid, and what we're really dealing with there is the HF, right? The species doesn't dissociate terribly well, so we really do have the HF. We have NaOH, which is a strong base, and what we're really worried about there is the OH minus. And then we have NaF, which contains our weak base. And that weak base in this case is just the F minus. So those are the four species we may or may not have present as we work on these mixtures. I want to look at the overall setup and then the specifics of this. Now this is an absolutely exhaustive setup of these examples. You may catch on much faster than you need with all these examples. So let's look at the overall buffer system of interest to us in aqueous dissociation. Something like HA, generic acid HA. That's not a real acid, but it's commonly used when you need some generic acid. And then we've got our aqueous dissociation equation, H2O. And we're going to get H3O plus. And our conjugate base, F minus. Now these are all aqueous. I don't really feel like writing all that out. We do have a Ka equation or whatever. I'm not worried about that either. But I guess I'll sneak that in. Ka is going to be not large. Alright, that means it is weak. Okay, so that's, I guess, an important factor for us. In this specific example, the acid-base system we're going to work with is HF and F minus. And you may recall me saying that, like, I choose that one all the time because it's the least writing I can do. HF just has two letters. So our specific system here is going to be HF and H2O, H3O plus, and our F minus. Now, in this particular case, our Ka is 7.2 times 10 to the minus fourth. So it's not large. This right here is our buffer system that we're going to be using. And the question is, how can we make that buffer system exist? And hopefully some combination of these things is going to allow that to exist for us. And what I want to do is look at the possible reactions we can have, because in the end we need some combination of our weak acid and our conjugate weak base. Okay, in the end we don't want these things, we just want some of this and some of this, and that's what we're hoping for. In fact, if we want to label it over here real quickly, NaF and HF. Alright, so what reactions can we have, or what reactions can we try to have? We can try to have the HCl and the NaOH, and I'll list these out. And it's going to get a little awkward as I try and do my color coding. But our first option would be HCl plus NaOH. In this particular case, that's a strong acid and a strong base. We're expecting a neutral solution. We're going to get water and NaCl. Alright, since HCl is strong and NaOH is strong, we don't have a buffer system. We don't have the HF or the NaF in this particular case. So this is not a system that's going to work too well for us. So this is, I'm just going to declare neutral at equilibrium. Therefore, it's not a buffer. Alright, so what is our next option? It would be the HCl and the HF. And HCl is an acid and HF is an acid, and so when you mix them there's no reaction. In fact, we get an acidic solution, and so that's not a buffer. Alright, I'm going to cross that one out. Our third possibility is the HCl and the NaF. So and I mentioned moments ago that I wasn't going to write in the spectators. Joke's on me already. Now, this is a strong acid and a weak base. In this particular case, we're going to end up with NaCl, which is essentially neutral. We're not worried about that. It's our spectator. And HF. So this is a big deal because now I have, and I'm going to get rid of my spectators, gone. So I've got H plus, gone. So I've got F minus, gone, gone, because they're both neutral. And then I keep that HF. In this particular case, then, we do have our buffer system. I have HF, and I have F minus. So this would be a buffer, all right? As long as we have excess F minus, we're going to end up with a buffer. So this is one of the situations where we're going to watch. And that is one of these situations we identified in the last video. In this particular case, excess weak base with a strong acid. Excess weak base with a strong acid. All right. Our fourth one is the NaOH and the HF possibility. So now this is promising because we've got strong base and weak acid. In this particular case, we're going to make H2O. No, really. H2O. And in this particular case, F minus. Again, I'm not looking closely at the spectators. This Na plus is gone. We've got OH minus and HF. We get H2O and F minus. So there's our weak conjugate base. There's our weak acid. That one is a buffer system. All right. So as long as this is present in excess, we do have a buffer system. Then we can take a look at the NaOH with the NaF. NaOH, strong base, and NaF. That F minus is our weak base, so that's no reaction, right? It's base only. And therefore, we can treat that as not a buffer. And we'll cross that one out. Our sixth option here, as I just realized that this is a 5, our sixth option here, and the only one left, is the HF and the NaF. Our HF is our weak acid, so that's something we need. Our NaF contains the F minus, which is something we need. Now, we're not going to get a reaction here, but we do have both species that we need for our equilibrium system, that F minus and the HF. And so this is a case where we do have a buffer. And we don't need one or the other in excess. In fact, it'd be nice if they were equal amounts. But this is a buffer. At its most basic level, you have a mixture of a weak acid or base and its conjugate straight up. Our goal at this point is to see which combinations here will give us something there, and our main priorities are the 3, the 4, and the 6. So what I'm going to try and do is label these as we go, which scenario we have, and we're going to squint and look at the stoichiometry here. All right, so these are the reactions we can have. These are the parameters we need, excess HF, excess NaF, with those things, or just a combination of those. In fact, I think it would be fastest, probably, and most efficient if we just look down the list here for a combination where we have, like, number 6. So, no, because I don't have both things. No, 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 yes, there we go. All right, so that particular situation is what happens in number 6. There's no reaction. I'm going to end up with 0.03, sorry, 0.3 for the HF, and 0.2 for the NaF. And so we do have a buffer in that case. And that is like number 6 there. Again, I'm just trying to skim through here and look for this scenario because it's the easiest to spot. Doesn't matter that they're not the same, doesn't matter that one's in excess, just matters that we have both. All right, so I don't have both, don't have both, don't have both, don't, there we go again, right here. We've got another situation that I could describe. We'll just call it number 6. These numbers are made up. It's not like in the textbook or something you're going to see, oh, that's a number 6 scenario. It's not going to happen at all. All right, so we do have a buffer there based on our number 6 option. And that's a yes. Yes, we do have a buffer. No, nope, 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 and nope. All right, So we've checked off every possibility of that. And now we're just looking for scenarios where we have excess weak base with strong acid or excess weak acid with strong base. What I might recommend, and what I should have said earlier, is that it'd be good if you paused the video or whatever and made some predictions in this column, because it's going to get super boring just watching me and then figuring it out as we go along. So pause the video, make some guesses. Maybe someday I'll put a copy of this spreadsheet in the comments section, but for right now, just go 1, 2, 3. We've got HCl and HF, that's our scenario number 2 here, and we've established that that's not going to be a buffer system because acid-acid, all right? So 2, the answer is no, and I'm giving up on my color coding here, 0.2 for the HCl and 0.2 for the HF. We don't have both of those things right there, all right? As we look at this one, we've got NaOH and HF. NaOH and HF is a scenario that could work as long as we have excess HF. However, we have stoichiometrically equal amounts. What are we going to end up with? Well, we have 0.2 of the NaOH reacting with 0.2 of the HF. We're going to make some water, and we're going to have some F-, and we'll have 0.2 of it. Again, I don't have both things, so that's a no. And while it is a number 4 scenario, it's not excess HF. So I'll just put a number 4 and a number 4 and a sad face to go with it, because it was close. All right, HCl and NaF. HCl and NaF is a scenario that could work as long as I have excess NaF. I don't have excess NaF. We're going to end up with 0.2 of our HF in this case. And then this is HF, HCl and NaF. That's our scenario number 3, which would work, but we don't have excess, so that one is not a buffer as well. All right, NaOH and NaF. NaOH and NaF is this number 5 scenario, and it isn't going to work because we only have bases there, in fact, strong base and weak base, so not a buffer. And then if you look over here, we end up with 0.2 of the NaOH and 0.2 of the NaF. Again, we're looking for scenarios where we have that combination of our weak acid and its conjugate base. All right, HCl and NaF, we said that scenario could work as long as we have excess NaF. Looks like we have excess HCl, so that's not going to work. It's an unsuccessful version of number 3, I guess. So sad face, because we've got excess HCl. We'll end up with 0.1 moles of HCl and then 0.2 moles of HF, so that's not going to work. Right here, HCl and HF, that's our scenario right here, our number 2. And as we look at it, no reaction, both acids. You're going to get the 0.3 right there, and you're going to get the 0.2 right there. So that is a no as well. We already established that that one's going to work. In this particular case, we've got NaOH and HF. That is our 4th scenario here. And the question is, do we have excess HF? And the answer is no, we've got excess NaOH. So this is another sad case because number 4 would work if we had excess HF. However, we're going to end up with 0.1 moles right there and then 0.2 moles right there of our NaF. Right here, HCl and NaOH, that's a number 1 scenario, and that's not going to work because strong and strong gives us neutral. So no, we end up with 0.3 of the HCl remaining, 0.1 of the HCl remaining, and then 0.2 of water. Again, we need stuff here and here. NaOH and NaF, that's base and base. Doesn't matter that one's present in excess. Since we have no reaction to the NaOH and the NaF, we stay with 0.3 of the one and 0.2 of the other. That just got worse, 0.3. All right, so this was our number 5 scenario, and that's a no. I know it's looking like everything's going to be a no, but we'll see how it goes. We've got HCl and NaF, that's HCl and NaF. As long as the NaF is present in excess, we're going to have a buffer system. HCl 0.2, NaF 0.3. Finally, we have a situation where we're going to make some HF. In fact, we're going to make 0.2 of the HF, and we'll have 0.1 of the NaF remaining. So that is a buffer system, finally. And that was based on our HCl and NaF, that's number 3. All right, 0.2, HCl and NaOH, we've already discussed this number 1 scenario. In this particular case, we're going to end up with 0.2 moles of water, no excess HCl or NaOH. 0.2 of the NaOH, 0.3 of the NaF, base and base, we're just going to keep those, 0.2 of the NaOH, 0.3 of the NaF, because there is no reaction. That's our number 5 scenario. And the answer is no. All right. HCl and HF, we've seen this before. It doesn't matter whether one is excess or not. We don't have a combination of acid and base, weak acid and weak base. So HCl and HF is this one right here. That's number 2, and it's a no. We end up with 0.2 of the HCl and 0.3 of the HF. NaOH and HF is right here. As long as we have excess HF, we should be okay, and we do. So that's a number 4 scenario that will work. I'm going to use up the 0.2 moles of NaOH, and we'll make 0.2 moles of that NaF, and we'll have 0.1 moles of that left over. And the last one here, strong and strong, doesn't matter whether one's excess or not, and so we end up with our number 1 scenario, which is impossible for it to be a buffer, and we end up in this case with 0.1 moles of the NaOH remaining. All right, so the short idea is, we had said you can either have a mixture of weak acid or base and its conjugate, and we said that that was going to be right here, weak acid or base and its conjugate. The amounts didn't matter as long as you had some of each. The amounts didn't matter as long as you had some of each. And then we can take excess weak base with strong acid, and we had excess weak base with strong acid. That's our number 3s that worked, and that is right there. Strong acid, excess weak made a buffer. And then we can also have excess weak acid with strong base, and that was our HF and NaOH, number 4. And we had some 4s that didn't work, but there was a number 4 that did work, excess weak with strong. So that's kind of an exhaustive set of examples, but hopefully you get the idea that these are the ways you can make a buffer. And we'll apply that in some specific buffer system analysis example.